So in conformity with our experience with this diet during the last 15 years, so it tells us that Yadkin was following this low carb, he was promoting a low carbohydrate diet for 15 years. And in fact, he is one of the first authors with a heavy science background discussing the low carbohydrate diet. None of our subjects complained of hunger or of any other ill effects. On the other hand, several volunteered statements to the effect that they had an increased feeling of well-being and decreased lassitude. And remember, when I went on this diet, I went on the diet because it said you'll lose your hunger, and I didn't understand it at the time. Now, Ansel Keys, who we also met yesterday, and who was the guy who argued with Yadkin, at the end of during the Second World War, he did a major study on the biology of human starvation. He took a group and he starved them for a reason he was allowed to do. He could never repeat the study. And what they found was that if you energy restrict people and give them a moderate carbohydrate diet, they develop semi-starvation neurosis. They begin to think of food all the time. And that's what happens if you put people on a calorie-restricted, low-fat diet. Calorie-restricted, low-fat diet. They get the semi-starvation neurosis. They're always thinking of food. They're always hungry. And that's why the low-calorie, high-carbohydrate diets don't work particularly well in the long term. And just to make the point that you cannot discuss diet and role in weight loss without discussing hunger, because hunger is the key point. So we move on to the next slide. And then this just shows parallel changes in carbohydrate intake and body mass index in the United States population. I introduced you to the body mass index, which is the picture on the right. And you can see that in 1965, that's the columns on the left, the males in blue and the women in right. Most people had a BMI less than 25 and they were lean. And I left school in 1966, and I can tell you every person in our matric class except one were lean. And the one guy who was fat, we thought he had cancer because we didn't understand what obesity was. And that's one of my privileges being so old, is I lived in a time when everyone was thin. So I've seen the huge change that's happened. So what happens, we introduced the dietary guidelines in 1976, and notice the BMI is pretty much stable up to that point, and then it just takes off for both men and women. That's the BMI. And let's look on the left. It tells us how the carbohydrate composition of the diet changed. And you can see that fat intake, notice in 1965, fat intake was the dominant constituent of the diet because it provided 44% of the diet, and the carbohydrate was only 38%. And I'll come back to that point. And then the fat goes down, it drops a bit, but by 1976, then it starts to drop more. And what is it replaced by? Increased carbohydrates. So I draw your attention to in 1965, a 38% carbohydrate diet would have been considered a high carbohydrate diet. 38%. Now we say a high carbohydrate diet is 65%. And a low carbohydrate diet is 45%. But in old terms, that was different. So even in 1976, the high carbohydrate diet in America was a 45% carbohydrate diet. But dietitians today call that a low carbohydrate diet. And that shows the extent to which we have changed our understanding in the last 20 or 30 years. This is another data from the NHANES data, and it shows what has changed in the American diet since 1971 to 2009. And the calorie intake, as I've shown you, has gone up 12%. And what has that been? Carbohydrates have gone up 30%. The consumption of carbohydrates has gone up 30%. The consumption of corn, which is our staple food, has gone up 100%. Vegetable oils, 89%. A massive change in the source of fat. So we've reduced the other fats and we've increased vegetable oils. Chicken has gone up and sugar has gone up. And red meat has plummeted down, by the way. So if we're looking for factors causing the massive rise in obesity, these are the factors we have to consider. We have to consider carbohydrates, we have to consider sugar, and we have to consider vegetable oils. And I mention this, that as obesity has gone up, cancer rates have gone absolutely in mirror image. And so if we're looking for cancer factors, we also have to look at those things as well. Now where did I get all my knowledge from? That's really important. So 5 years ago, I didn't know anything about these low carbohydrate diets. And I have a couple of bookshelves, and this is the one just dedicated to books on low carbohydrate diets. And so I read about diabetes, about cancer, about the biome, which is our gut flora, the diet-heart hypothesis, the dietary fat, sports nutrition, obesity, sugar in the diet, wheat in the diet, infant nutrition, and those are all the historically important low carbohydrate, high fat diet books. And then those are the ancestral diets, which I talked about yesterday. These are the disproof of the diet-heart hypothesis. This is addiction, which we're going to come to, and then those are DVDs. And you see, the problem is that if you don't read this stuff, you don't know what's out there. And so much of the information hasn't yet got into the scientific literature. But we were told in expert witness from the complainant that if the book is not peer-reviewed, it's meaningless. But then how do you learn things? I have an extensive library, and I read a lot of stuff. And so I bought a few books which are not peer-reviewed. And I thought we could begin with William Harvey, De Mortu Cordis, the most important book in science probably, which described how the heart was, how Harvey decided how the heart worked. This was not peer-reviewed. Darwin's On the Origin of Species was not peer-reviewed. Principia, which was Newton's book, was not peer-reviewed. No one could peer-review it. They couldn't understand what he was talking about. And then Galileo Galilei, the one who's really important because he suffered for his opinions. That was never peer-reviewed. So my view is that peer review is no excuse not to read books. And of course, 50% of what they say is going to be wrong. But that's fine. You just decide which 50%. And I'm briefly going to just discuss peer review because I understand peer review. In fact, this is an article I wrote in the British Journal of Sports Medicine. I was a senior author for this article because I was so unhappy with how I'd been treated over the years that my work was not properly peer reviewed. And so we developed this section of the British Journal of Sports Medicine where if you felt your article had not been properly peer reviewed and there was bias against you, you could send it to this journal, and we would consider it. And you'd send us all the other reviews, and then we would decide whether you'd been fairly treated. So to say peer review improves science is not true. It doesn't. It maintains the orthodoxy. And that's terribly important to understand. Because if I'm the editor of this journal, and I don't want your paper to be published because it conflicts with my ideas, I will send it to a reviewer who I know will reject it. And that, unfortunately, is the features of peer review. And the most famous example is the two guys who win the Nobel Prize, two Australians. And we wrote in this article, challenging this view, pathologist Warren and clinician Marshall observed that curved gastric bacteria was associated with peptic ulcer disease. This led to an entirely novel treatment regime, antibiotics, and to an entirely new research area into possible infective triggers of common disease. And here's the point. Was their innovative discovery greeted with excitement by their peers? Because that's what you would think should happen. If you suddenly know, maybe we were wrong, we should change. Apparently not. And this is the letter that Dr. Marshall received. Dear Dr. Marshall, I regret that your abstract paper was not accepted for presentation for this meeting. 67 abstracts were submitted. We could only accept 56. And he won the Nobel Prize a few years later. But the point was that it's very difficult to get a contrary opinion accepted in medicine. And that's the basis of why I'm here today, to give the evidence in open court that it's very difficult to get out into the public domain.